Okay, let's take a look at this identity we have here. We want to prove that the left-hand side is equal to the right-hand side. And the way to prove an identity in trig is always the easier ways to start with the side that looks more complicated. That at least gives you some starting point, and hopefully you will be able to show that the left-hand side is equal to the right-hand side. So I'm going to start with the left-hand side. That looks like it's more complicated. Now for the left-hand side, it's similar to having two fractions. Of course, in order for us to add them, we have to have the same denominator, least common denominator, which means I have to do some fraction action here. The fraction on the left-hand side needs to be multiplied by 1 minus sine of x, of course, numerator and denominator. That's what's missing on the left-hand side. And on the right-hand side, we're missing a cosine x. Cosine x. So what I always do is I write my denominator first because that's now the same. 1 minus sine x, put it in parentheses, times cosine x. Which order you write that makes absolutely no difference. Okay, so my denominator is taken care of. Now I have to work in the numerator. In the numerator, we have to multiply 1 minus sine x times 1 minus sine x. So let me do this. I want a different color. 1 times 1 is 1. Minus sine of x, and then we do minus sine of x, and negative sine times negative sine is a positive sine squared of x, and these two are easy to multiply, plus cosine squared of x. Okay. Now, what you need to be able to recognize based on the identities that you learn in trig is that the sine squared plus the cosine squared is equal to 1. So I call these the most important formula identity in trigonometry. Sine squared plus cosine squared is equal to 1. Let me combine like terms now. I'm still on the left-hand side. I have a 1 here, and I have this 1 that gives me a 2 minus, and you can clearly see that I have 2 sine x's, so minus 2 sine of x all over 1 minus sine x times cosine x. Okay. You always do one side with the end result in mind. I need a 2 secant x out of this expression. How do I do that? Well, another way we have to do this now is to see if we can factor. Can we factor anything in the numerator? And it looks like both terms have a 2. So I'm going to continue writing here because I have not much room left there. I factor out a 2, which is my greatest common factor. And if I factor out a 2, I'm left with 1 minus sine. Oh, look at that. Sine of x all over 1 minus sine of x. Beautiful. Times cosine x. So I simplified, I factored. Oh, can I reduce here? Oh, yes, I can. 1 minus sine x and 1 minus sine x reduces to 1, which leaves me with just a 2 over cosine x. And you know, by definition, 1 over cosine x, that is the same as the reciprocal, the secant of x. The 2 stays in the numerator, and 1 over cosine x changes into secant of x. Guess what? Which is my right-hand side. And I just have proved that the left-hand side is equal to the right-hand side. That's it. Done we are.